Hello participants, now we are going to see how Simulink model is prepared, and we are going to prepare Simulink model for three-phase SPWM inverter. So and this is MATLAB 2013B, and in any version of MATLAB you will see this particular type of window. This is default layout, and here I am having current folder. Here this is the command window, this central part, and this is workspace, and this is command history. Workspace stores values of different parameters after simulation, output parameters after simulation in the given 1D or 2D array type. Here we can get this parameter. So the first step I would like to do is to change the path of this directory. I am interested to change the folder here, so I'll be copying the path of in the folder in which I am interested, and now I have changed the folder. In this folder I am already having one particular simulation which is already done on the same topic, that is three-phase SPWM inverter, but this will be only for reference, and here we will start with our new Simulink model. Like this, new Simulink model is selected, and yes, this is our new Simulink model. So before proceeding, I am interested to save it, and we will give the name like SPWM underscore inverter, right? This is a generic name, simple name given to our Simulink model. And now this Simulink model, you know, is available here. The SPWM inverter here. Okay, so now to start with, this is a library browser. So most of the components required, we can fetch most of the components from here. So as you know, uh, with the time limitation, I cannot discuss all these blocks. These are commonly used blocks, then continuous, discontinuous, discrete, so many blocks are there, sinks, sources. So you have to spend a lot of time with MATLAB to understand all these uh, blocks. And we are having sim powerscape also uh, here, simscape also. So here also, from here also, we can get lot of tools required, like sim electronics is there, then sim power system is also there. So a lot of required components we can get from simscape, or a lot of components we can get directly from Simulink, or even if we are not aware where that those components are placed, we can directly enter here the search term, and then we can get that particular component. So for this Simulink model, I will be entering the term here only. We know we want 16 different components. Already list is discussed with you with my presentation, and I'll start with the first component. And to start with, I'll start with the sine wave. So I'll start I will start with this sine wave block, and I will check whether my sine wave gives me proper output. For that I will go with the scope. So this is our scope, and now I have connected the scope like this. Now my job is to create three-phase sine waveform. So first of all, I should check whether this scope is properly giving us the sinusoidal value. Yes, it is given. Now you must be observing this is 0, this is 10, this is 10. So this much time for 10 here, this 10 value is inserted. This is simulation stop time. So I am interested in very small time. This is simulation. I will be entering 0.2, and if now I enter, now I will get this sort of, this is auto scale, so I will get this sort of waveform. This is exactly not the sine waveform. So what to do here? Open this block. Amplitude is 1. I don't have any problem with the amplitude, but here I can change the frequency, and it is radian per second. So 100 into pi will be your 50 hertz frequency. You may go for details of it. You go through this particular instructions shown over here. You will get why 100 into pi is inserted, because it is in radians. And phase, yes, phase, I am happy with the 0 phase, so I'll apply here. Okay, I'll again rerun it. Now see, now I am going to get this kind of waveform. This is sinusoidal but not exactly sinusoidal, so I will make some changes. Please observe carefully model configuration parameters in the simulation, and here I have to make some changes. So maximum step, here I will enter E5 into E to the power minus 5. I am entering very small step here, and this will help, I hope, to get us, yes. So we are going to get sinusoidal waveform, and you must be observing that 0.02, that means one cycle is completed into 0.02 seconds. So 10 cycles, I am interested in to test my system for 10 cycles, and that's why I have kept the simulation time 0.2. I know that one cycle is of 0.02 seconds, because we for 50 hertz 1 by 50, 0.02, that is 20 milliseconds, and 10 cycles are sufficient. If you are interested, you may increase this particular time also. So just for setting, we can go for 1.0 also, for just for example. So here we get uh, sinusoidal waveform, and we are observing from 0.75 to 1. So in particular this description, yes, limiting data to last 5000. So uncheck this, otherwise now you are going to get last 5000 points only, last 5000 points of this waveform. Now if I simulate it again, then here now I am going to get from 0 to 1. So many cycles we got. Earlier we used to get only 10 cycles up to 0.2, and now we are observing around 50 cycles. So my dear participants, we don't need these many cycles, only it adds to confusion. I will restrict myself for 10 cycles for this particular simulating model. You have flexibility to go for any number of cycles. So please remember that you have to go to simulation, then model, configuration parameters, and only in one uh, place, that is maximum step size, you change it. Don't keep it in auto mode, right? That will help you, because we have selected this particular solver variable step, and we are having this particular solver. There are number of solvers, and each solver will behave little bit with little bit difference. And in this particular video I am not going to give details of each and everything. I am limited We are limiting ourselves with this particular completion of this particular Simulink model. It is also going to consume some time. So this is our sine wave number 1. So I am going for second, and I am going for third. So I am writing here R phase, then I am writing here Y phase, and this will be our B phase, right? And similarly we can have scope here, right? Another scope, or we can use mux also, that was shown in our presentation. We can use mux also here. And in Y phase, so again, as said earlier, I don't have any problem with the amplitude, then frequency is already set, but phase, so here I have to change the phase. So it will be minus 2 pi, so we want minus 120 degree phase difference. So it will be, just a minute,